Good day, ladies and gentlemen. This is Sarah van Grennen, aka Mr. VG, and thank you for joining me in video 2 in our series on grade 11, paper 1. So we are looking again at the Department of Basic Education, November 2020, Gauteng paper. Again, I'm not just going to stick religiously to this paper. In some of the videos, I am going to give my own twist on it, maybe ask you some extra questions. So stay tuned and let's dive into equations. Now, I just said this is part 2 because it covers a lot of different types of equations, but equations as we expect it in the exam. So I'm going to challenge you to go for it. Try and do this question 1.2, all of it. Take maybe 20 minutes or 25 minutes. Try these sums yourself first, and then you look at the rest of the video. So when we look at these questions, they are stock standard, what I could expect in the exam, even right through till matric. So let's look at question 1.2.1. Solve for x. 2x squared minus 3x minus 4 equal to 0. Again, please run through it in your mind. Don't just run into the question. First, let's analyze. It's a quadratic equation, okay? Why do I know that? It's got an x squared in it. Then I need equal to 0. So that is perfectly fine. I've got equal to 0. But now they kind of give me a clue there in brackets. They say correct to 2 decimal places. So in my mind, I automatically go, I need the quadratic equation. I need that formula, okay? Almost the formula to A. There we go. Again, I look for clues, kind of like breadcrumbs that the examiner is giving for me. So if I've got that, I know that I've got A, B, and C given to me in the equation. Again, only because it is equal to 0. So if I go to my formula, x equal to negative b plus minus b squared minus 4ac over 2a. Please don't put in more steps than this. You put in this, go to your calculator, plonk it in, and it gives you that as the simplest surd form. If you have a fancy 991ZA plus, or just the ZA, or the ES, it can solve that expression in one step. But, ladies and gents, if you are a public school student, you need to know that we want to see that step. Okay, even though your calculator can solve it, we want to see that you can use the formula. If you're in an IEB school, your teacher might be more lenient and say, whatever, just give me the answers. But please go to your teacher and ask them what is fine. What are they fine with? If they want it to 2 decimal places, well, we give it to them to 2 decimal places. But please make sure that you read the instruction. If they say 2 decimals, round off proper. Please, this is one of the few questions where we will deduct marks if your rounding off is not right. Okay? Let's look at the next question. Question 1.2.2. First of all, what is the difference between this and the previous one? The biggest difference is it is an inequality. So the moment I see an inequality, I know that I've got to draw a graph, okay? If your teacher showed you a table instead of a graph, that's 100% right. I don't mind. I just don't like that method, okay? For me, it's a lot of extra work. But please use the method your teacher shows you. For me to draw the graph, I first need to actually know what kind of graph we are working with. So let's distribute those brackets out, and I've got a quadratic equation. For quadratic equation, remember, I need a 0. I took everything to the right-hand side. Why? Because I want to make my negative 2x squared a positive. Okay, that's just for me easier. If you feel it easier to divide straight through by negative and have your inequality sign swap around, that's 100% fine. But I'm going to now write it in standard form. So writing it in standard form, I've got that expression. Remember, I'm reading from the x value. So I've got 2x squared minus 3x minus 5 smaller than 0. I need the critical values, so I am going to factorize and get my critical values, my x-intercepts, okay? So that is the points where my expression is equal to 0. Remember, even though it doesn't say equal to 0, it doesn't, I'm still going to look for the critical values. Next up, I'm going to draw my graph. It's a smiling parabola because it is a plus 2x squared. I'm looking for smaller than 0, okay? I'm looking for smaller than 0. So I'm going to close off the bigger than 0 part, and I'm left with that expression there at the bottom, okay? Next up, I'm going to just write my answers. X is between negative 1 and 5 over 2, or 2,5. Look, I love fractions because they are accurate, they are on point, okay? So what I'm going to do is that is my answer. You can also write it like this. X lies between negative 1 and 5 over 2. It doesn't equal to negative 1 and it doesn't equal to 5 over 2. Also, there are no equals. There's no place where this graph is undefined or non-real or anything. It's a normal expression. So I've got no places that I need to exclude. Let's look at the next question. The next question is solving that third equation. For a moment there, I lost the word. Oh my goodness. I lost the word third equation. A very, very, very important thing, ladies and gents, is that you have to get your third on its own first. Okay. Now, I'm going to, at the end of this video, explain to you why you've got to get your third on its own. But let's first follow the basic steps. I need to get the third on its own. I need to isolate it. So I'm transposing, or I'm subtracting x on both sides. Now I can square both sides. Squaring both sides gets rid of my third on the left-hand side and gives me a quadratic expression on the right-hand side. Hence, I've got to get equal to 0. So I am subtracting x and 2 on both sides, leaving me with an expression that looks like that. Last but definitely not least, I now have to solve that expression. Factorizing in this case is relatively simple, so x minus 7 and x minus 2, giving me x equal to 7 or x equal to 2. So please, please, please remember, you are not done. You are not done with this sum. I know it feels like you're done, but you are not. What must you still do? You have to test your answers. So if I substitute 7 at the original expression. Please get this. You need to use the original expression. Not one where you squared both sides or isolated, the original expression. I get 10 on the left-hand side. But on the right-hand side, I've got 4. So is 7 a solution to this equation? And the answer is no, it isn't, because the left-hand side gives me 10, the right-hand side gives me 4. So x cannot be 7. What about 2? If I substitute 2 on the left-hand side, I get 4. On the right-hand side, I get 4. So hence, x equal to 2 is a possible solution. Awesome. So please remember this. You are going to lose a mark if you don't test. You don't have to show the test, but you've got to test it, and left-hand side must be equal to right-hand side. So as promised, I'm going to quickly show you why you cannot just square both sides at the beginning. I feel like this is very important for you to understand. If I look at root of x plus 2 plus x equal to 4, if I square the sides, and please understand, you cannot square individual terms, you've got to square sides. Then, on the left-hand side, I'm going to sit with a bit of a nasty one, because remember, this is x plus 2 in a root or in a surd, and then another x plus 2 plus x. If I multiply out, I'm going to sit with x plus 2, because the surds divide away. But then I'm going to sit with x times by root x plus 2, which is that one there. And in the middle, I'm going to sit with another x, root x plus 2. And then I'm going to sit with my x squared for those ones. Now, ladies and gents, I am sitting with a humongous issue in our middle terms. So please understand that you cannot just square before you isolate. You will get 0 for the rest of the sum. Whatever you do, you will get 0. So the very important things in this one is, remember to isolate my surd, and then after I've solved it, I have to test which solutions are equal. Let's look at the last one, ladies and gentlemen. The last one. So when we look at this the last equation we need to solve, it now becomes, it's actually given as a exponential equation. Okay, exponential equation, because I've got my x in the exponent. What makes this different from a quadratic equation? Well, remember, with a quadratic equation, I'm trying to get something equal to 0. With an exponential equation, I'm not trying to get equal to 0. I'm trying to get, for instance, 2 to the power of something equal to 2 to the power of something else. That is my end goal. Okay, so I need to get my power alone on one side. That is my end goal. Okay, so get that difference. Okay, but for me to do this, I've got to try and first get the bases the same. So I've got basically 3 different powers, and there are pluses and minuses in between. So I know, I've got to factorize somewhere, okay? See how my mind works, is I see powers and pluses and minus, so I'm thinking about factorization, okay? That's where my mind goes. So I'm going to make my bases the same first of all. So I'm going to change the 4 to the x into 2 to the power of 2x. Each of the powers are kind of the same. They've got the same thing in, which is a 2x. Okay, so I'm going to split up my exponents, okay, which is reversing the first law. And now I can take out 2 to the 2x common in every term on the left-hand side. So I am going to replace every 2 to the 2x I take out with a 1. I love to do this because then I know I'm not going to lose something. So everywhere there's a 2 to the x or 2 to the 2x, I put a 1. Okay, it's just something for me to make sure that I don't miss it. Okay, I don't want to miss something. So when I look at this, I'm now gonna go and simplify inside the bracket. So I'm going to multiply those ones out. I'm moving this 2 to the negative 1 under the 3, making it 2 to the positive 1. I'm adding those ones in the bracket and it gives me 3 over 2 because 2 plus 1 is 3 minus 3 over 2. Well, that is just 3 over 2 or 1.5. Next up, I'm still not having my 2 to the 2x alone. So I'm going to times by 2 over 3 on both sides. Because, remember I'm doing this because the 2 and the 2 is going to divide away. And the 3 and the 3. So I'm multiplying by the reciprocal. On the right hand side, I've got 12 times 2, which is 24, divided by 3, which is 8. So in other words, I now have the 2 to the 2x on its own, on the left. So what must I do with that 8? Get the base as 2 to the power of 3. My bases are now the same. Therefore, my exponents are also the same. Please understand this. I'm not dividing by 2 both sides. I'm not scratching them out. I'm not subtracting them. Because the 2 in the bases are the same, therefore my exponents must also be the same. Because left is equal to right. So it's equating the exponents. It's making them equal. And therefore, x is equal to 3 over 2 is my only solution. Sure. This was an awesome video covering a lot of different topics, starting with the quadratic formula, then over to inequalities, surds, and exponents. Ladies and gents, you need to get all of this as part of your exam. Please, please, please. These sums are going to feature there. Somewhere it is going to feature. So have a beautiful and amazing rest of your day. Tune in to the next video, which is our last video on equations. So have a beautiful and amazing rest of your day. This is Mr. VG signing out. Cheers.